In this video, we're going to talk about what it means to solve a differential equation. That term is used quite broadly, and it can mean a lot of different things depending on the type of problem that you're dealing with. So let's suppose that we have an equation, something that looks maybe like y prime equals y, and we would like to find a solution for that. Well, there are various things that you might do. The best case scenario is you might actually be able to construct a nice formula for exactly what that function is. So an explicit solution would be something like y of t equals e to the t for the constant. So that's nice because given a value of t, we can immediately find the value of y. And there are plenty of differential equations where that is possible. On the other hand, you may find that that is not going to be possible for certain problems. And in those cases, what we'll sometimes live with is what's called an implicit solution. Something like perhaps ln of y equals t plus c. You'll notice that this does give us a relationship between y and t, but it doesn't tell us directly how to compute y. We'd have to do a little bit of algebra to try to find y once we've got a value of t. Now in this case, it's simple enough to take this implicit solution and turn it into an explicit solution, but there are examples of situations, things like y squared plus t squared equals c squared, where we can't just find a single expression that gives us y from t. Okay, so those are what you might call analytical solutions. These are nice symbolic formulas that allow us to determine the solution. There's another type of solution that sometimes you will construct when you cannot seem to find an analytical solution, and I'll show you these in the next slide. So there are two types here. On the left, we have what you might call a graphical solution, and it is a sketch for what we think the curve looks like. Now in this case, the sketch was generated using the help of a computer. It used some information about the slope of the curve and used that to figure out how to trace out the entire curve. So a graphical solution is great in the sense that it gives us a sense of the shape of the solution, but it's only an approximation. It doesn't give us precise values for the unknown function. And then the last type of solution that you might construct is what you might call a numerical solution, and this is just a table of values. Again, a computer is very helpful for constructing these sorts of solutions, but they give us a matching between some of the values of the independent variable t and the dependent variable y. So we will talk about how to construct all of these types of solutions at different points over the course of the semester, but in general, we would like to find an explicit solution if possible, since that gives us the most information. If not, we'll live with an implicit solution, and when both of those fail, we'll opt for one of these graphical or numerical solutions instead.